Listen closely. I want you to think about the world you see around you right now. The colors, the shapes, the light. It all feels so complete, so continuous, doesn't it? But what if I told you that what you're experiencing isn't the raw, unfiltered truth? What if I told you that your brain literally erases parts of your vision every single day, and you never ever notice it? I'm going to tell you something that sounds completely nuts, but it's a fundamental, scientifically proven fact of how you perceive reality. This isn't a metaphor or a philosophical riddle. It's a biological process happening inside your head, right now, as you watch this. Every single day, with every blink of your eyes, with every rapid shift of your gaze from one point to another, your brain actively erases parts of your vision. It doesn't just ignore the information, it actively suppresses it. It just deletes them. Gone. Poof. Vanished from your conscious experience as if they never happened. Think about it. When you blink for about 100 to 150 milliseconds, your world goes dark. That's a significant chunk of time. But you don't experience a brief moment of blackness, do you? You don't feel like you're watching a flickering movie. Your brain papers over the gap. And it's not just blinking. Your eyes are in constant motion, darting around 3 to 4 times every second in movements called saccades. During these lightning-fast shifts, your vision is essentially useless, a messy, motion-blurred smear. If you were to see that raw data, it would be nauseating. So your brain hits the mute button on your optic nerve for those few milliseconds. It cuts out the visual static. We're not talking about a tiny blip here and there. When you add up all the little moments, every blink, every saccade, every micro blackout, the blackout time can reach nearly 2 hours every single day. Let that sink in. For a full 1/8 of your waking life, you are functionally blind, and your brain is hiding the evidence from you. That's like watching an entire feature-length movie with your eyes shut. Except you never realize the film stopped. Your brain doesn't just leave a black hole where the information should be. It does something far more clever. It takes the image you saw, just the blackout, and the image you see, just E, and it masterfully stitches them together. It creates a plausible, seamless bridge of perception. Your brain performs this deception so seamlessly, so flawlessly. You walk through life utterly unaware of the constant gaping holes in your perception. You believe you are seeing a continuous stream of reality, but what you're actually seeing is a heavily edited reconstruction, a best-guess narrative. Now, this might sound like a bug in the system, a glitch in our biological hardware, but it's not. This isn't a flaw, it's a feature, a profoundly important one. Your brain is a master editor, and its top priority isn't to show you the messy, chaotic, raw footage of reality. Its job is to build a smooth, stable, and useful story of the world around you. A story you can act on. To do this, it has to make compromises. It sacrifices a little bit of raw, moment-to-moment accuracy in order to deliver a stabilized, coherent, high-definition feature film of your life. Imagine if it didn't. Imagine if you saw every jerky eye movement, every moment of darkness from a blink. The world would be a dizzying, unnavigable mess. You wouldn't be able to track a moving object, read a line of text, or even walk in a straight line without feeling disoriented. So your brain's editing process is essential. It cuts out the noise, the blur, the darkness, and the jarring transitions, presenting you with a final cut that feels continuous, stable, and utterly real. It's the most incredible special effect in the universe, and it's happening for you, constantly. But this raises a profound question. If our brain is constantly editing our reality, filling in gaps, and making assumptions, what else is it changing? Where is all this missing time going? And more importantly, what is the brain filling it? Is it always an accurate reconstruction? Or does it sometimes get it wrong? This hidden process explains so much, from how we fall for optical illusions to why eyewitness testimony can be so unreliable. It affects how we play sports, how we drive our cars, and even how we interact with the digital world. In this series, we're going to pull back the curtain on your brain's secret editing room. We'll explore the neuroscience behind these blind spots, test them out with illusions you can try at home, and uncover how this constant act of creation shapes your entire experience of life. If you're fascinated by the hidden secrets of the human brain, subscribe and turn on notifications, because you're not going to want to miss what comes next. Like this video if your own mind just became a little more mysterious, and save it as a reminder that what you see isn't always what you get. Now let's look at the mechanics of this vanishing act. The first culprit is happening right now as you read. Your eyes are jumping. They don't move like a camera pan. Instead, they make rapid, jerky movements, saccades, about 3 per second. Mid-flight, the image is a useless, blurry mess. So your brain temporarily shuts down visual processing, saccadic suppression. The instant your eye lands, vision switches back on. Your brain stitches the before and after into one. It's so effective you can't see your own eye move in a mirror. Next up, blinking. You blink 15-20 times a minute, over 15,000 times a day. Each blink plunges the world into darkness for 100 to 400 milliseconds. It adds up to a real chunk of time. Do you notice it? No. Your brain fills in the gap using before and after frames. Finally, a permanent hole, your natural blind spot. Where the optic nerve exits, there are no photoreceptors. It's a literal hole, yet you don't see it, because your brain fills it in. All of this happens automatically, without your permission. Let's imagine Tony walking through a busy city park on a sunny afternoon. He's on the phone, eyes darting everywhere. He glances at a dog catching a frisbee. That's a saccade. His brain suppresses the blur. Phone, dog, none of the messy smear in between. The world remains perfectly stable. The grass stays steady, the dog moves smoothly. A gust of wind, Tony blinks. For a moment, it's pitch black, yet his path stays continuous. He never feels a break. He looks right. His gaze lands on a jogger. A bench falls on his right eye blind spot. Gone from that eye's data. But his brain fills the gap with context, and both eyes together restore it. He's unaware of the thousands of edits just performed. His memory feels continuous and unbroken. Behind the scenes, the brain cleaned up messy input into a usable reality. Tony's world feels steady and whole, thanks to this invisible editor. Have you ever considered that the world you see isn't a direct one-to-one recording of reality? Instead, your brain acts as a masterful editor, constantly working behind the scenes to create a seamless, coherent experience. One of its most remarkable tricks is a process called perceptual filling in. In essence, your brain abhors a vacuum. When it encounters a gap in the sensory information it receives, it doesn't just leave a blank space or a patch of static. That would be disorienting and confusing. Instead, it makes an intelligent, educated guess. It analyzes the surrounding context, the colors, the textures, the patterns, the lines, and fills in the missing piece with the most plausible information it can generate. This isn't a random fabrication. It's a highly sophisticated act of inference, a prediction of what be there based on everything around it. Think of it like the content-aware fill tool in photo editing software. When you select and delete an object, the software doesn't leave a hole. It samples the pixels around the gap and synthesizes a new background that blends in perfectly. Your brain is doing this constantly, in real time, without you ever noticing. It's like a master art restorer, meticulously painting over a crack in a canvas, using the nearby colors and patterns to make the repair completely invisible. The most famous example of this phenomenon deals with our physiological blind spot. In the back of each eye, there's a tiny area on the retina where the optic nerve, the data cable connecting your eye to your brain, passes through. In this specific spot, there are no photoreceptor cells, no rods or cones to detect light. It's a literal gap in your visual field. So why don't you see two black holes floating in your vision all day? Because of perceptual filling in. Let's prove it. If you were to take a card with a repeating pattern, like these stripes, but with a small physical gap in the middle, and position it just right so that the gap falls directly onto your blind spot, you would report seeing no gap at all. The brain, detecting the consistent striped pattern on all sides of the missing information, simply completes it. It paints the stripes right across the void. The textures from the surrounding area get cloned in automatically, creating a flawless, uninterrupted image. It's a powerful demonstration of your brain prioritizing a complete picture over a perfectly accurate one. On a neural level, this is fascinating. The neurons in your visual cortex that correspond to the blind spot don't just go silent. Instead, they become active based on the signals from their neighbors, the neurons processing the areas the blind spot. It's a beautiful example of neural collaboration, working together to construct a complete and stable scene from incomplete data. You can experience this right now, no special equipment needed. Go ahead and try this with me. Hold both of your thumbs up at arm's length side by side. Now close your left eye and fixate your gaze entirely on your left thumb. Really focus on the nail, the knuckle, every detail. Don't let your eye wander. Keeping your gaze locked on that left thumb, slowly slide your right thumb away to the right. Keep it at the same height, just moving it horizontally. At a certain point, something amazing will happen. The top of your right thumb will simply pop out of existence. That's your blind spot. The light reflecting off your thumb is hitting that nerve-packed spot on your retina, and your brain is receiving no data. But notice what you see in its place. It's not a black hole or a blurry smudge. You see the wall behind it. You see the pattern of the wallpaper, the color of the paint, the texture of the bookshelf. Your brain has seamlessly filled in the gap with the background information. Now, open both eyes. And just like that, your thumb is back. The information from your left eye has filled in the gap from your right. This constant collaboration between our two eyes is the primary reason we rarely, if ever, notice our blind spots in daily life. But filling in isn't just for physiological holes. Your brain also edits out irrelevant information to keep your world stable. Let's try another quick experiment. Find two distinct points in your room, maybe a light switch and a picture frame a few feet apart. Now I want you to watch a second hand on a clock or set a 1-second stopwatch. We're going to move our eyes, but only for a very brief moment. For the duration of that 1 second, flick your eyes back and forth between the 2 points as fast as you can. Go ahead. What did you see? You probably have a clear perception of the light switch and a clear perception of the picture frame, but you almost certainly did not perceive the blurry, streaking smear of the wall in between. The rapid movement of your eyes is called a saccade, and during that motion, the visual information you receive is essentially useless, a high-speed blur. So, what does your brain do? It performs a trick called saccadic masking. It cleverly cuts the visual feed the moment your eyes start to move, and only turns it back on when your gaze lands on the new target. It throws away the blurry, confusing data from the journey, and presents you only with the clear, stable endpoints. It's another form of filling in, but this time, it's filling a temporal gap, not a spatial one. These simple at-home demos pull back the curtain on the extraordinary, constant, and completely invisible work your brain is doing every waking moment. It's not just a passive receiver of information. It's an active, predictive, and creative force, constructing your reality from the ground up. It fills the gaps, erases the noise, and delivers a world that feels whole, stable, and effortlessly complete. So why go to all this trouble? Survival. Build a stable, actionable model, not record every photon. Dirty data in, signal processing out. A blackout-filled feed would fail at spotting danger, food, or footing. It filters noise and enhances what matters: faces, words, cars. Constancy keeps size and color stable despite changing input. Sometimes the guess is wrong. That's an illusion. The brain prefers continuity, even where none exists. Magicians exploit saccades and suppression to hide moves. Timing of saccades and blinks can have consequences. You might look at keys, but if attention never tags them, you're blind to them. Training can reduce misses. Structured scans, attention discipline. Designers place critical info in central vision. Flashing alerts capture attention. Slow your gaze, deliberately scan. Notice details you'd miss. Athletes learn gaze control to minimize gaps at critical moments. Understanding the exploit lets you compensate and see more. In the end, after all the science and all the wonder, we arrive at a profound and slightly unsettling truth. Vision, the sense we trust above all others to show us the world as it is a beautiful, elaborate, and entirely necessary fabrication. It feels like a crystal-clear window, a direct connection to reality. But it's not. What you perceive as the world isn't a passive recording of photons hitting your retina. It's an active, dynamic, and deeply personal construction. Your brain isn't a window, it's a storyteller, and it's the most masterful storyteller in the universe. It takes the raw, chaotic, and surprisingly incomplete data stream from your eyes and gets to work. It's a director, a cinematographer, and a world-class editor all rolled into one. It weaves this incomplete data into a seamless, stable tapestry of experience. The world you see feels whole, continuous, and rich with detail. But that feeling is the story. The reality is a stream of noisy, disjointed information, riddled with gaps and imperfections. Your brain's prime directive isn't to show you the truth in all its messy glory. Its job is to create a version of the truth that is useful for survival. And to do that, it has to hide its own work. It hides the cuts, edits out the bloopers, and fills in the plot holes with breathtaking efficiency. Think about the saccades we explored. Those rapid, jerky eye movements you make 3 to 4 times every single second. Each one should produce a nauseating motion blur, a chaotic smear across your vision. But you see nothing. The editor simply cuts that footage out. Over the course of a day, this adds up to hours of functional blindness. Those 2 hours aren't a loss, they're a sacrifice for coherence. It's the price of admission for a stable world. The same is true for the 20,000 times you blink each day. That's another 30 minutes plunged into total darkness, yet you never notice the lights going out. Your brain anticipates the blink, momentarily suppresses the visual signal, and then skillfully stitches the before and after frames together. The show goes on, uninterrupted. And what do you get in return for allowing this masterful deception? Everything. In return, you track motion smoothly, you spot friends in a crowd, you read a line of text without the words blurring into an incomprehensible mess. You can drive a car, catch a ball, and appreciate a sunset. This constant invisible editing is what makes a functional life possible. We evolved to be blind to the trick, and perhaps more profoundly, we evolved to be blind to the fact that we're blind. It's a feature, not a bug, honed over millions of years to give us an evolutionary edge. And the deception runs even deeper. It's not just about missing time, it's about missing space. Right now, in each of your eyes, there is a permanent hole, a blind spot where the optic nerve connects to the retina. There are no photoreceptors there. It's a patch of total blindness, roughly the size of 15 full moons in the sky. Yet you see no black holes floating in your vision. Why? Because the storyteller fills them in. It takes information from the surrounding area and from your other eye, and paints over the gap with a plausible guess. All while these 2 permanent holes are painted over by context. So when you look out at the world, remember what you're truly seeing. You are not looking out. You are looking in. You live inside an exquisitely rendered simulation, a high-fidelity virtual reality generated in real time by the 3-pound universe in your head. Every color, every texture, every sense of depth and distance is a product of its incredible computational power. It's a private screening of the world, curated, edited, and produced exclusively for an audience of one. Starring you. This grand illusion of sight is just one of the countless secrets your brain keeps from you, all in the name of helping you navigate your life. There is always more beneath the surface. Our perception of time, our memories, our very sense of self, they are all subject to the same masterful storytelling, the same helpful edits and convenient fabrications. The more you learn about the brain, the more you realize that reality is not something you passively observe, but something you actively create, moment by moment. And that is an incredibly empowering idea. It means you have a role in the story. By understanding the storyteller, you can begin to appreciate its artistry and even learn to see its edits. So stay curious, keep asking questions, challenge your own perceptions. The more you learn, the more amazing and intricate reality becomes. Don't just accept the final cut your brain presents to you. Get interested in the editing process. Now you know about the blind spots in your vision, the saccadic masking, the constant edits that create your stable world. You've peeked behind the curtain, but this is just the beginning. What else isn't your brain telling you? How does it construct your emotions? How does it decide which memories to keep and which to discard? The rabbit hole goes so much deeper. If you want to keep exploring the hidden secrets of your own mind, make sure you subscribe and turn on notifications. We release new deep dives into psychology and neuroscience every single week. If this video blew your mind or gave you a new appreciation for your own brain, hit the like button. It really helps the channel reach more curious minds. And save this video to your watch list so you don't forget these incredible facts. What part of this process surprised you the most? Let us know in the comments below. Thanks for watching.